Okay. Hey, I'm very excited to be here. Today, I'm going to share with you some of our Azure internal AI agent training experience. So today, I'm going to walk through that. In the Azure cloud, we are developing the AI agent with the MI300X Instinct GPU. And I will kind of walk through some of the difficulty and some of the training tips to all of you. So first of all, right, this internal training is a production training for the AI agent. It's targeting for the Azure AI and HPC production usage internally. This is a joint development with the Microsoft Research Vancouver team and my engineering team together. So the goal is trying to develop this AI agent to improve the efficiency in terms of the time of the training as well as the resource usage. So now, I'm very excited. A couple of weeks ago, we have been finished the first part of the small training. And this small training actually able to be done with the 17 billion MOE model and trained it with MI300 only for 9 days and able to handle a 4.8 trillion token. So the number of GPU we are using is a 1,300 GPU. So the result is actually very impressive, right? It's a time that we actually learning that, hey, the MI300X GPU, the large HBM, were able to help us to going through this kind of training, and the result is actually very impressive. I will be able to share more detail later with all of you. First, right, AI training is not a typical software development. So this is actually a software and hardware combined effort. So the cluster is actually very complicated with all this high performance GPU, a lot of large number of the interconnect, and then the workload also need to train at least a multiple day, or sometimes even talking about like 20 or 30 days, right? So very important part of it is I'm very glad that I'm working with the Microsoft research team. They are very helpful and able to help out on all these challenge on it. You can see the part is that you are going to have a lot of GPU checkpoint failure. You need to restore it. You need to find out what is going on and try to restore the training as soon as possible. As you see from the table on the left, you can see the first week we actually spend a lot of time to restore the GPU checkpoint. Then later on, when we work with the AMD team, able to bring up the AMD training platform, and also our in-house training tool, we are 60% reduce the restore time to a 13.9. Then later on, after all the tool and everything stabilized, we are actually achieving like 73% reduction. So from that point on, the customer really spend most of the time to do a training job, right? Keep that in mind, this is very expensive, right? Time is money. If more of your time, the GPU cluster is sitting in idle, then you are wasting a lot of time and money. So you want to really minimize the restore time on it. Now, later on, I will share a bit more detail. Now, let's look at the result first, right? So again, this is just only a beginning, right? You go through all the training, you go through all the experiment, fine-tuning, everything on it. Now you get 9 days later, you get a very decent model come up. The very important part we learned is actually you need to develop your own benchmarking, right? First, you can, in this example I share with you is a public benchmark like MMLU on that. You want to go through those kind of benchmarks to make sure your model is meet a certain level of the artificial intelligence. And of course, with your custom data, you also need to develop your own benchmark to make sure the model actually do what you expect to do, right? Now, I will highly recommend invest a lot of development resource into this area because it will be very beneficial for you to kind of moving this training in a multiple cycle. Now, with this, right, this small model, we actually, you look at the blue line here, you can see we do a multiple attempt on the training. The result is actually very, very good. So far, we find the MI300X is continue to scale well, right? It's not blocking us to continue moving the model forward. So as you see on the MMLU, our small model actually able to be in the parity with the industrial frontier model on it. So that is very encouraging. Now, at this point, right, we are moving forward on the gray line area that we are trying to scale up the model to the larger model on the 300 billion parameter model. So far, I will say the training haven't been complete, but the performance is continue to scale well on it. So we are very encouraging with the result so far. Next. Now, looking back, I would like to share about 3 different tips to all of you. So first, server cluster health is very important. I would highly recommend take the first few days to really examine the entire cluster in terms of software and hardware. It will going to be very, very beneficial for you because you don't want to deal with all these things in the middle of your training, because the time you should spend on doing the training is keep reviewing your training result, trying to optimize or maybe try to even refining it. So you should not spend time on deal with like one of the optical cable link job, or some of the GPU performance actually lower than the other, or maybe some of the system I/O problem. Keep in mind, this kind of system is actually very, very complicated system, right? So in this example, you can see the chart here we're showing is a number of GPU checkpoint, right? You can look at it is if number of GPU restore checkpoint is kind of proportional to how productive your training is. In the first week, we spend a lot of effort to reduce all these bad software, hardware, make sure the latest Wacom library, latest AMD training platform software install. Then you can see the number of these checkpoint restore is significant job in the week 2 and 3, 4 on it become more manageable. So again, right, spend the time prepare for that, right? Because this is not going to be a easy one, right? You should really focusing on your researcher, your developer should focusing on the time is the model efficiency and refinement on it. It's not trying to deal with the infrastructure. Next, right? You need to make sure that, hey, you really, in this point, I will really grateful to say AMD engineering team is very awesome. The software team actually provide a very quick turnaround. Now, one part of it is we do that in a very careful step. We actually build in a lot of locking and diagnosticability in the training on each of the nodes. So AMD actually provide a very quick turnaround in terms of a feature request and also the hotfix. In this example, right, is an early time when we do the experiment, the single node experiment, we find a lot of problem on this is the machine actually suddenly disappear, right, from our point of view. So actually the machine is entire thing crash. So turn out AMD able to quickly provide a workaround in very short time. We're able to apply it and able to restore the work going forward. So I think the key is make sure that you have the latest AMD Wacom library and also the AMD training platform software install. It really working well nowadays, right? Now, next one here, right? This is one of the examples we saw recently is, early time on that is, hey, we do not know why suddenly we see the training divergence is not correct, right? In this case, you look at the red line, it somewhat is, we don't understand, right? So later on, we're looking at it, we learn one thing very hard on it is, training, most of the time people talking about is performance. But actually, you should be very careful thinking about it is reliability. Every change you're going to bring in, either from your researcher or from AMD or from any firmware in the system, you want to make sure the reliability meet the bar. For example, you should take the change into one particular machine and do a stress run on it to make sure it stays. Don't just go in to pick up a lot of good fix and jump it in. It's going to hurt you. In this case, we take a very high performance change on it, but turn out the correctness is not there. That's why you see the divergence is not come up okay. After we pull back to use a more reliable one, even though they're a little bit slower, but turn out they are actually able to get you a better result so that you can come back to do a better performance tuning later. Does that make sense to all of you? I think this kind of thing is really different than a typical software development that, let's see how the thing goes and put the debug on. You cannot do that. This is like the first model we do is 1,300 GPU. When the thing doesn't work, it's not an easy thing to say which one doesn't work. If you don't able to pick it up, what happened to you is an hour later, you're going to stuck in the same place, right? So really spend time on those infrastructure, and it will going to help you really focusing on the result instead of spending all the time with the infrastructure, with the software stack, okay? Now, let me just put a quick summary, right? So first, in terms of training, I would say I'm very glad that we actually using our Azure infrastructure to do the training, the storage, the security part of it, right? The capacity management. For example, when I have a machine down, I will easily to bring up the other machine instead of trying to push through the RMA and try to get all these machines come back in order to get my 2,000 GPU functional. So, and then on top of it, you want the platform support all the open software and also have very good partnership with AMD, able to take the latest software stack and apply it to provide a better experience. Now, on top of it, I think like the previous speaker mentioned, right, really try to leveraging the open source community, right? A lot of reliable software out there like the MS SQL++, we were able to provide you a better scaling, and then there is a better telemetry software and other library will help you to get further on it. If you're interested for more detail, come by, right? We can share with you more detail about different kind of the tuning tips, right, to kind of get you going on it. At last, I'm really thankful for the AMD team support, right? This is not a simple thing. I'm very glad that we are able to prove that just using a 9 days able to complete such a difficult training. And I will be looking forward to come back to share with you the next time the 300 billion model complete and with more results. All right. Again, thank you.